my name's John Marks, this is Thibault Deheurles with Adaptive. And our talk today is on trading in the Cube. Before I get into the main body of the presentation, I just wanted to get an idea of who's in the room. So who's a developer here? Okay, probably about half of you. What about DevOps? Any DevOps guys? Okay, slightly fewer. And then anyone working within financial services or writing these sorts of apps? Great, okay, so we've got a nice broad spectrum. So a little bit about Adaptive. So we're a software consultancy. We're based in London. We're about 35 or 36 people at the moment, but I have to count every day because we're growing quite rapidly at the moment. And we work mainly in financial services, so particularly for investment banks, hedge funds, and so on. And we write trading software. What we'd like to discuss today is a bit about the fundamentals of how we actually build trading applications, some of the challenges that they pose to us, how technologies like Docker and Kubernetes can help us achieve this. Then we'd like to demonstrate a sample trading application that we've built, and then an exciting announcement. One other thing I should say is if I fall asleep mid-presentation, my wife gave birth to our second child on Tuesday, so I'm running on vapor at the moment, so someone give me a kick. So thank you very much. Oh, even better, so thank you very much. So trading applications, what are the requirements? Well, firstly, the user interface has to be responsive. So there is nothing worse than an irate trader if he hits a button and he doesn't see the trade status come up immediately. And what he will tend to do is keep mashing that button until something happens. You would hope it's the right thing, and he's not trading several times. The other things we have to do is we have to push live updates, so be they prices or execution events. So they're not your traditional web apps. The system has to be resilient, so if we have a server-side outage or whatever, the deal needs to happen. The deals are worth a lot of money. If they fail to execute, then we're in trouble. They have to be scalable, so the load that goes through these sorts of systems is not flat throughout the day. There are extreme peaks. And also the development should be agile. So a bit about live updates. So we need to push prices. And when I say push prices, we need to do so with low latency. And low latency in our industry means single-digit millisecond. Even on web apps, it is achievable, but we really have to optimize for that. And what that means is that polling a RESTful API to get prices, have I got a new price, have I got a new price, that just isn't going to cut it. So it introduces far too much latency, and also it scales terribly on the back end. So we can use technologies like WebSockets. However, we find that often, or more often than not, they're blocked by corporate networks, by certain firewalls and so on. So we need a fallback strategy. And there are several, so things like server-sent events, forever frames, long polling. And in the past, to do this, we've used commercial products. Nowadays, though, there are open source alternatives that are every bit as good. So resiliency is very important. Murphy famously said, anything that can go wrong will go wrong. Generally, it will happen during an important event like non-farm payroll, and almost certainly at 3 a.m. when I'm asleep, or when my baby boys just got to sleep and wake me up when I'm on call. So we need to be resilient to all sorts of things. So resilient to process crashes, to server failures, to network outages. And this means that we need to run multiple instances of every back-end service, and that when we partition services into those that are stateful and stateless, the stateful ones have to be coordinated such that their state is replicated. These applications need to be scalable. So trading volumes vary greatly throughout the day. There are peaks, obviously, at market open and market close, but also during certain economic events. So non-farm payroll I mentioned, triple witching, interest rate announcements, but also for no reason whatsoever. So there can be spikes in the market and you have no idea why it's happening, but there's a rally or a dip, and we have to be alive throughout all of that. So traditionally what we've done is we've designed for the worst possible case, so throwing as much hardware as we can to the solution or as we can afford. The downsides to this are, firstly, it's very expensive, and secondly, humans just aren't pessimistic enough. So, we think that we have a setup that will cover all of our possible needs. Invariably, it's not the case. Something comes up that surprises us. So it would be nice if applications would scale automatically according to the demand. And it would be nice if we only paid for what we needed at that time when we needed it. So we need to be agile. So trading applications, they tend to be written by large teams. So the teams tend to work across various different asset classes. So particular teams would do foreign exchange, another one would do bonds, and so on and so forth. And those teams are often based in geographically diverse regions. And those teams, they will often have different deployment windows, so they have certain targets they're trying to meet. What this means is that if you try and arrange your releases into big bang releases of the entire monolith of the application, well, firstly, it becomes too hard to test because there's just too much functionality there. And it becomes increasingly more difficult to coordinate teams to hit a particular time slot. So what we found is that it's not uncommon for banks to release once a year or twice a year, which really it's not agile enough. Their competitors will run rings around them in the future. So there has to be a better way. So what we do is we partition the applications into various independent components. We adopt a microservices architecture, and different teams, therefore, can own a whole vertical slice of the application, from the data all the way up to the presentation. And if those vertical slices are completely isolated, they can be developed, tested, and deployed independently of each other. In order to do this as well, we leverage container technologies. And these guarantee isolation. They give us a known runtime environment, and it means that also we can easily promote Docker images between environments. So we know that the component that we test in development and then promoted through UAT to production is running exactly the same libraries, exactly the same OS image, and so on. So now I'd like to introduce I was going to say a product, but it's more of a sample application that we've developed in order to demonstrate some of this technology. We call it Reactive Trader Cloud. So it's a successor to a previous incarnation called Reactive Trader, where the emphasis was on reactive programming. But in this case, we've taken that concept and we've deployed it to various cloud technologies. So it's a sample foreign exchange trading application. It pushes real-time prices. It has a trade blotter where we can see trades being done and the state of trades that have been executed already. There's a live analytics section with charting, and there's the URL there. You can hit that if you want and take a look at it. To go through the architecture of what we've built. So the front end is HTML5. It's built as a modular composite application, meaning that the various different components are loaded and assembled at runtime into the UI. We use React.js for an MVC library. And then we use a library called RxJS. So I don't know if anyone's heard of reactive programming, but we're big fans. And this helps us to deal with things like streams of data and reason about asynchrony. And then to push prices, we're using WebSockets via the WAMP protocol. And the particular library that we're using is Autobahn. On the back end, we have a WAMP message broker. So we're using Crossbar here. And then we have a set of microservices. They're written in .NET and running in Linux under Mono. Very shortly, they'll be running under DNX as soon as that's ready. And then the database layer, we actually use a distributed event store. This is a transaction log style quorum-based event store that allows us to scale the back end and also use a quorum-based approach for consistency. We deploy within Docker containers, and then all of this is running within Kubernetes on Google's cloud platform. So just looking briefly at the architecture diagram, so we have a UI connected to a message broker, and then a set of microservices that plug into that broker, and then finally our database layer, this event store. So this is different from a traditional web app, as I said before. We're not hitting just a bunch of RESTful services. Everything here is routed through this WebSocket once we establish it with the broker. Okay, time for a demonstration. So let's bring up the app. So this is Reactive Trader Cloud. So I can take you through the various different components here for those that aren't familiar with trading applications. So firstly, in the top left area, we have a series of tiles, each of which represents a foreign exchange currency pair. So you see euro, dollar on the top left. And then we see a pair of prices. So this is the bidder or the ask, the buy or the sell price. And you'll see that there's a spread between them. And then in each tile we have sort of a ticking chart that shows you the trend of prices over time. In the bottom section we have a trade blotter. So Thibault, if you care to execute on one of these. We'll see that he's executed on New Zealand dollar USD. We saw within that tile an update to say it was sold. He's doing it on Euro JPY now. That one errored. So some of them are, for demo purposes, configured to error or timeout. Can you just try another one, Thibault? I think you probably get the same result every time on that one. Okay, so there's one that went through. And then we see that we're getting status entries come into the blotter at the bottom, so we can see the trades that have been done and those that have been rejected. So on the right-hand side here, we have an analytics section. And this shows you the current positions that have been accumulated by the trading activity that we've done. And also we can see the profit and loss as it changes throughout the trading activity. And then finally, on the top right, there's a little section with some indicator numbers that will become increasingly important as we go through the rest of the demo. But what these represent here are the various different microservices behind this, their current status and the number of instances that we're running of each of those. And then the sort of connectivity bars to the left just tells how good our connection to this WebSocket backend is at the moment. So Thibault, if you'd like to go through a live demo, that would be great.
Hi everyone, can you hear me? Yeah.
A little bit louder.
Okay, so we will show, we're using Google Cloud for the demonstration. So is a running demo. We can see, for example, I will list the namespaces. Is everyone fine with the Kubernetes and controller all these things? So we have all namespaces, and we can see here the demo that is running. Sorry, here. So we have some information on how is running the demo at the moment. Sorry. So we had all different services. So we have broker, event store, and web. Replication controller that are running at the moment. We are running only one replica of each one. So we have the analytics, the blotter, the pricing, reference data, trade execution that are the backend. The web is here. We can see the broker and the event store. And finally, at the moment, we are running on 2 nodes that we can confirm on Google Cloud. So let's have a new deployment. So I will deploy. You can see here we are looking to the web in the namespace demo. So the service web at demo. So I will try to connect to. Sorry, not Mac. We will create KubeCon. So for now, we have no KubeCon. We deploy KubeCon, and I choose a version that have been built. So we have all the container for, it's the build number of our Reactive Trader. It's the 966.
So we can see the things it's doing here. So firstly, it's created a new namespace. So for us, that's a completely isolated environment, nothing to do with the demo one. And then it's set up the various replication controllers. And now we're seeing the status of that environment as it's coming up.
So the web is on. We can see that the broker is here too. The different services are starting. Listen. So the different containers have been started. You can see they are all present. At the moment, all the code is starting. And you can see,
okay.
For example, the blotter that is coming.
Pricing. Great. So that's a live deployment of the app. It's completely isolated from what you've seen before.
So if we go back, we can see that we have a deployment KubeCon that is sandbox for with demo. We can deploy lots of environment if we want. For now, we are still on two nodes. We can look if we stop. We can scale, for example, the analytics. So I will scale in the KubeCon the analytics service to 0. Just confirm that it's done.
So we can see there the analytics service is now terminating. You can see.
Replica. And is terminating. Just need to wait a little moment for him to. Kubernetes is stopping it, not killing him, so just wait a few. We can see here that we have moved to 3 nodes now. So Google Cloud is auto-scaling when you need more space. So we have started a new node.
Okay, so the analytics pane here has completely disappeared. So the front end is designed to basically show as much functionality as it's possible to show. So when the analytics backend went down, the UI makes a call which is, okay, this has gone offline, I'm going to shut down that whole component, but the rest of the application stays functional.
So I scale back to, I add some analytics. We will add 3 analytics. We will scale the different services now. We can scale, for example, the pricing. Sorry. We can add the reference data read. Execution. Yeah.
So we can see now that for these various different microservices, we're running now 3 instances of analytics, 3 of pricing, 3 of the reference data one, trade execution. So if we flick back to the application, we'll start seeing these come online. So we can now see 2 of, I think that's reference data. Analytics is up to 2 now. Execution is up to 2. We've got 3. I think that's analytics. Okay, so everything's come up. The front end has picked up with them. If we look back at the console, we'll probably see that we've scaled to another machine.
Yeah, sorry.
Yeah, so we're still on 3 VMs, but if the load increases, then this auto-scaling group will naturally throw more instances into that pool.
I'm deploying a new environment. You can see the node scale. So we just have added another part is this in front of the Kubernetes, we just using one IP, and we have an Nginx that when you get make a virtual hosting for the service web and the namespace KubeCon. So when I start a new environment, I can go to it at the same moment. I already know where it will be. So I have started web KubeCon 2 cluster con should be fine. Yeah, and you can see it's starting a new environment. Maybe we can try running that.
Yeah. So what Thibault is going to try and do now is a rolling update, which is to try and upgrade one of the microservices of this live running system. So in this case, which one are you going to choose?
So we will scale. For example, we have the KubeCon was deployed in version 9.6.6. So for example, I will switch analytics to 9.6.2. It's another build. So try. Find that KubeCon. What I've forgotten. I don't know. Well, forget this.
Okay. Cool, we'll move on.
So yeah, here demo, here.
So let's just take down the environment now. That's an interesting thing to see.
And here a different one. It seems that this deployment, the pricing has not started. I can try to remove it. KubeCon 2. Pricing has not started. Scale to 0. Well, as with the new Kubernetes, it's coming with the auto scaling of the cluster. For now, we are using the auto scaling from Google Cloud. So when the CPU is under 550 or something like that, Google Cloud tell this node, I kill you, and Kubernetes understand that all the services are done and it restart them. So in the new version, it will be Kubernetes that will do that, and we won't have this kind of issue.
Can you just kill the KubeCon environment? Just delete it.
Sure.
Okay, so what Thibault's doing now is just deleting the KubeCon environment that we created. So, and then if we go back to the original KubeCon, not KubeCon 2.
And everything is there.
So everything's gone. So, I mean, what we've showed you there is how simple it is to spin up an entirely new environment, scale down services that the UI is responsive to those. Then we can scale up the Google Cloud Platform will also scale that group of instances, and Kubernetes will assign containers to those various nodes on the cluster. And then we've torn down an environment all in the space of a few minutes. So using previous technologies, we'd be gone for days or weeks to do this sort of stuff, and now it's really this simple. So if we can go back to the presentation. Thank you. So in summary, what we've talked about so far, some of the challenges that we face in building trading applications. We've discussed how Kubernetes can be used to facilitate the rapid building and deployment of these sorts of apps. We've demonstrated a sample FX trading app, created and destroyed environments, showed resilience to service failure, showed the ability to scale services, and we've dynamically provisioned resources. So I promised some exciting news, and that news is that we're open sourcing this whole application today. So you'll be able to find it at github.com, Adaptive Consulting, Reactive Trader Cloud. And in fact, what I will do is I will go to that repository now and flip the bit to make it public. So yeah, it doesn't get any fresher than this. So to the danger zone, no way back. Done. So thank you very much. So we'd love you guys to get involved. Please check out the code. Tell us if there's things you like, if you don't like. Submit pull requests. We're delighted to accept them. And if this is the sort of stuff that's interesting to you, come and talk to us at Adaptive. Here's our various contact details. Sorry, they're at the end. We'll get to there in a second. Now, any questions at all? As I say, please be gentle. I haven't slept for 3 days. And Thibault has naturally all the answers. But anything anyone would like to know? Yes?
There should be a microphone, right?
Oh, yeah.
So let's use that.
I'm working in the industry right now.
Okay.
But before I was in a small forex trading company was run from Abu Dhabi.
Okay.
And and some of the infrastructure was in Paris and where your accent comes from.
No.
And then the infrastructure moved to London to be closer to the feeds and the liquidity providers.
Yeah.
And the application. So what's your business model? How do you want to disrupt this market?
Right.
And is it particularly for these distributed teams where latency time matters? When they click a price, they want to buy this price. And
sure. So, I mean, the stuff we've showed you today, we don't actually sell as a product. It's something that we give away and also we use as a sandbox that we can test out new technologies and so on. But our day-to-day work is for investment banks and hedge funds, and they all have their own environments. So some of them are cloud-based, some of them are on their own private data centers, but we try and employ as many of these technologies as we can. But the thing you said about co-location, some of our clients certainly do that. They do co-locate their data centers with direct feeds to exchanges. So I guess it's a long-winded answer to say it depends on the client. We'll do whatever they need us to do. But
is the scaling, for instance, when the liquidity providers, when there is high volatility and the liquidity providers send suddenly lots of prices, so the pricing engine.
So that will be the use case. So if we detect certain spikes in the market or we see that volumes going through our pricing services are ramping up and up and up, then we will spin up new instances in real time. Okay, any other questions?
Yeah, I'm interested in this idea of splitting up a monolithic application into microservices. I can see lots of benefits there. How have you handled version compatibility? So, for example, you have your trading microservice, which relies on your pricing microservice to execute the trade. You deploy a new version of your pricing service, your trading service is aware of the old version. How have you handled that sort of?
So there's several answers to that question. The first is that you define clear APIs between your components and you version those APIs. And it's kind of the proto-buff rule, which is you never take anything away. So you can add new fields to your protocols without breaking old ones. And what you would do is you kind of march ever onwards, but you leave old instances of your services behind you. So you'd leave 1 or 2 prior versions from the past, and then when everyone stopped using them, you remove those. So you keep marching ever onwards by adding new services, supporting old protocols and not taking down old instances straight away.
So I was just wondering what level of uptake of containerization you've seen at sort of banks around London to date?
Yeah.
Because obviously investment banks tend to be
I'd say
conservative, I guess is the polite word for it.
So far it's been slow, but it's snowballing now. And I spend most of my time at a tier 1 investment bank who are very actively trying to migrate their single dealer platform. So that's their showcase client-facing trading platform. They're migrating it to public cloud at the moment, all running in Docker, and that's my day-to-day. So it's happening, it's inevitable. Some are adopting these technologies faster than others. They're all going to get there because they have to.
I'm just curious how you deal with the compliance issues, data replication, availability, high availability in the public cloud, and are there banks moving that way without? I mean, data residency is also important. Yes. How do you deal with all that?
It is certainly important. There are issues with data residency. So some countries have different regulations than others. We have in the past had to partition data into customer-specific data and non-customer-specific, and make sure that customer-specific data is stored in particular countries, well, particular data centers in particular countries, so that it is conforming to the regulation for that particular regime. In terms of the high availability, so we basically do everything that we would have done in private data centers. So absolutely everything is replicated across regions, and then within regions, the banks in their private data centers have long had multiple availability zones, in particular, well, around particular cities. So generally it's New York, London, Tokyo, and so on. And we find that maps very well to what the public cloud providers are doing. They're solving exactly the same problems. And then in terms of how are the regulators about the banks adopting these technologies? Well, actually, the first movers to get their infrastructure were the regulators themselves, in that they're finding that they're having to deploy ever more software to implement their own regulation, and they don't have these massive data centers, so they're having to do it to public cloud as first movers. So the banks are kind of following them in a regard, which is a strange situation to be in.
Are you using traditional databases though on the back end, or using container-based databases?
So it depends on the particular client. So in the stuff that we demonstrated here, we're using Event Store, which is not a traditional database. In others, we use traditional SQL databases, so MySQL, lots of Oracle, basically whatever the bank had. But we're also seeing an uptake of NoSQL as well. What I would say is, if these applications are so large, it isn't a one-size-fits-all answer. So you'll often find traditional SQL databases and NoSQL databases working for various different components of the app.
I'm sorry, so in your UI, in the top right-hand corner, you had the icon to show you how many
services,
yeah. How did you do that? Just out of interest.
So what's actually happening is all of the the microservices are broadcasting their availability to the message broker. And then the UI is listening to a particular topic through the message broker, and it's seeing how many instances are running for each service. What I would say is, as well, each microservice not only broadcasts that it's available, it also says what its current load factor is. The point being there that the UI is programmed to go for the service instance that has the lowest load at that time. So naturally, we find that there's a sort of spreading of load, that as you run hundreds or thousands of instances of this front end, that they will naturally scale evenly across the back end. And what it also means is that if one particular service instance does go down, then only a fraction of the UIs will see a disturbance, and then they will immediately fail over to the least weighted next instance of that service. So, we built a lot of these systems and learnt a lot of lessons along the way. And one of those being that if you have all instances failing over to the same service, you get a sort of network storm, and you tend to get this cascade of failure or a death spiral, as we call it. So these sort of strategies are employed to ensure that doesn't happen.
Sorry, are you saying that the UI is doing the
load
balancing? Why not the message broker?
So it could. but we feel that rather than making the message broker very smart and storing things like the state of current subscriptions to the back end for the various different pricing tiles, the best thing to do that, the part of the system that has the most knowledge of those subscriptions is the UI itself. And so it can work out where best to direct and what services it needs. Otherwise, we need to hold all sorts of state in the message broker about who subscribed to what and where information needs to be directed. So having built this a number of times, and we've built it using the strategy that you described, we find that this one is simpler and works better for us. Sure.
Actually, I'm really interested in knowing how you maintain such low latencies when you're dealing with public cloud and so forth. But since that's a really open-ended question, let me just ask you.
What I would say is when I talked about single-digit milliseconds, in that particular, by the way, if this hasn't actually failed, we see if there's no activity for 15 minutes to save our pennies. We we shut down the UI, so we wouldn't do that in a real application. But sorry, what was the question again? I have been away for 3 days, so.
Hey,
latency, yes.
I'm from the States. I know all about being tired now.
So the latency one is the single-digit milliseconds we talk about are on dedicated data centers for particular banks that have optimized for this. They aren't the sort of latencies that we've seen from public cloud so far, but we're not seeing crazy latencies. We're still seeing around 10 milliseconds, that sort of thing. So just out of the box, by using the inbuilt load balancing of the public cloud offerings, and for our web front ends, things like Nginx, and then by routing all of the data flow through message brokers and WebSockets as opposed to traditional RESTful services, we get a huge win there. So that data pipeline is established and stays hot for the entire session.
Well, which message brokers are you using?
So in this case, it's using Crossbar IO as a backend. So and the client library is called Autobahn.
Another question? If not, I'm in awe.
Thank you.
Show that the URL to your site and to the open source
Yeah,
project.
so you'll find us here. Our website is weareadaptive.com. We're on Twitter. You can email us. But so go to the newly public Reactive Trader cloud repository, knock yourselves out, and have fun.
Awesome.
Thanks, guys.